Tonight, while you sleep, your brain will replay every important experience you had today. It will flush a liter of toxic waste from its own tissue, and it will deliberately paralyze your entire body so you cannot act out your dreams. If it does not get the chance to do this every single night, the effects begin within 17 hours. You will not notice them at first. That is the first symptom. Before we go further, subscribe to Human Decoded. We break down your body every single week. Sleep is not when your brain switches off. In many ways, it is when your brain starts doing its most important work. Sleep is not a single state. Every night, your brain cycles through 4 distinct stages in roughly 90-minute loops, and each stage is doing something completely different. Stage 1 is the transition from wakefulness. Light, easy to disrupt. Your muscles begin to relax, and you may experience sudden jerks or the sensation of falling. Your nervous system briefly misreading the shift in muscle tone as a loss of balance. Stage 2 is deeper. Your heart rate slows. Your body temperature drops by about half a degree Celsius, and your brain begins producing rapid bursts of neural activity, 12 to 14 electrical pulses per second, called sleep spindles. These spindles are now understood to be a core part of how your brain decides what to remember. Stage 3 is deep sleep, slow wave sleep. This is the most physically restorative stage. Your pituitary gland releases the majority of your daily growth hormone here, the chemical signal that repairs muscle, bone, and tissue. It is hardest to wake someone from this stage, and the damage from losing it accumulates faster than any other. And then there is REM, rapid eye movement sleep. This is where things get strange. During REM sleep, your brain becomes nearly as active as it is when you are fully awake. Oxygen consumption spikes. Blood flow to the prefrontal cortex, the region handling memory and emotion, surges. Your eyes move rapidly beneath your lids as if tracking something. This is when dreaming happens. But here is the part most people do not know. During REM, your brain deliberately sends signals to your spinal cord that switch off all voluntary muscle movement. You are paralyzed from the neck down. You cannot act out what is happening in your dreams. This is called REMatonia, and it is a feature, not a flaw. In a rare disorder called REM sleep behavior disorder, this paralysis fails. People physically act out their dreams in real time, shouting, swinging, running, with no memory of it afterward. When the system works correctly, you have no idea it is happening at all. Here is one of the most well-documented and consistently overlooked facts in all of sleep science. One night of good sleep after learning something new improves your ability to recall it by 20 to 40% compared to staying awake. Not slightly better, measurably, significantly better, and the difference is already visible after a single night. This happens because of the hippocampus, your brain's short-term holding area. During the day, it absorbs information rapidly, tagging experiences as they happen. During sleep, it replays those tagged memories in compressed form, transferring them to the cortex for long-term storage. The replay happens at roughly 20 times normal speed. Pulling an all-nighter before an exam does not give you more time to learn. It eliminates the consolidation window. The information sits in the hippocampus unprocessed, and by morning, much of it has already begun to fade. In 2013, researchers discovered something that changed everything about how we understand why sleep is non-negotiable. Your brain has its own dedicated waste clearance system called the glymphatic system, a network of channels surrounding blood vessels that pumps cerebrospinal fluid through brain tissue, flushing out metabolic waste products that build up during waking hours. During sleep, particularly deep sleep, this system becomes 10 times more active than during wakefulness. 10 times. One of the primary waste products it clears is beta amyloid, a protein that accumulates in the brains of people with Alzheimer's disease. Every night, a functioning glymphatic system clears it out. With chronic sleep deprivation, clearance is impaired. The protein builds up. Over years, this may be one of the mechanisms connecting poor sleep to the early development of neurodegenerative disease. This is no longer a theory. It is an active area of clinical research. After 17 hours without sleep, a normal late night, your cognitive performance begins to measurably decline. After 24 hours, it is equivalent to a blood alcohol level of 0.10%. In most countries, that is legally drunk. Your reaction time, decision-making, and memory encoding are all impaired to that degree, and most people in this state believe they are functioning normally. After one bad night of sleep, the activity of natural killer cells in your immune system drops by up to 70%. One night. Your first line of defense against viral infection is cut by more than two-thirds after a single poor night of sleep. After 72 hours without sleep, hallucinations can begin. The brain starts generating its own sensory input to compensate for the deprivation. So here is what your brain does tonight while you are unconscious. It cycles through 4 stages roughly every 90 minutes. In stage 2, sleep spindles consolidate memory. In stage 3, deep sleep, growth hormone repairs your body and your glymphatic system begins flushing toxic waste, including proteins linked to Alzheimer's. In REM, your brain becomes nearly as active as waking, paralyzes your body, and processes the emotional content of your day. Miss enough of this consistently over months and years, and the effects compound. Cognitive decline, immune suppression, and accumulated neural waste that your brain never got the chance to clear. Sleep is not optional maintenance. It is the only time your brain can do what it cannot do while you are awake. Follow for more. Every video, we go inside the body and explain exactly what is happening. If your body just surprised you, subscribe to Human Decoded. We do this every week.